In this video, we'll talk about linear equations in two variables, and we are going to graph linear equations using plotting points and using slope-intercept form. So this form, ax plus by equals c, it's called the standard form of an equation of a line. So it has two variables, x and y, and a, b, and c are real numbers. So let's take a look at some examples. Let's take a look at these examples 1 through 4, where it says, graph the following linear equations by plotting points. So I'm going to do example 1. So example 1 is 2x plus 5y equals 10. And I want to graph it by plotting points, which means x and y. I know they are linear equations, which means the graph is going to be a line. So that means 2 points are enough. So I'm going to say if x equals 0, so here, if x equals 0, we get 5y equals 10, which means if we divide both sides by 5, y equals 2. So here we get 2. Then we can give x another value and find y. So let's say x is 5. I could give any value I want. I could say x is 1 or 2 or 3. But just for computational reasons, x equals 5, it's a good choice. Because 2 times 5, right, I'm going to replace x with 5 here. 2 times 5 equals 10, plus 5y equals 10. If we subtract 10 from both sides, we get 5y equals 0. If we divide by 5 both sides, we get y equals 0. So here I'm going to put 0. Now I'm going to plot these points. So the way we plot them in the pair 0, 2 and the pair 5, 0. So this is the origin, x and y. 0, 2 means 1, 2, bubble that. And then 5, it's 1, 2, 3, 4, 5 is the x. And y is 0, so we bubble this. Now we connect the 2 points. And this is the equation of the line. This should pass exactly through 0, 5. And this is the graph of the 2x plus 5y equals 10 by plotting points. And actually, the points that I chose, they're also called the intercepts, right? This is exactly the y-intercept, and this is exactly the x-intercept. Now let's graph x equals 5 by plotting points. So again, I'm going to make a table of values, x and y, and I'm going to give 2x. Well, because x equals 5, the only value that I can give to x is 5. Y can be 0 and y can be 1, because y can have any value. The only one that stays constant is x equals 5. So when we plot the points, x or y, 5, 0 would be this point, and 5, 1 would be this point. Now, if it's still unclear how the line goes, let's say we make up one more value. If x equals 5 and y equals 2, then it would be this point. And then if x equals 5 and y equals 3, would be this point. So we got the idea that the graph, it's of x equals 5, it's a vertical line that is passing through 5. And let's take a look at the fourth example. 3y equals negative 6. If we divide y by 3, we get y equals negative 2. So now let's give values, x and y. Y, the only value that it can have is negative 2, while x can be any number we want. So I'm going to give these 3 values. So when we plot them, x or y, if x equals 0, y is negative 2. If x equals 1, y equals negative 2. If x equals 2, y equals negative 2. So when we connect the points, we notice that y equals negative 2, or 3x equals negative 6. It's the same as the horizontal line that passes through -2. So now, think of these two questions. What line is x equals 0? What line is y equals 0? So make a table of values, x, y, and if x equals 0, put 0 everywhere and then just give values. Graph the line, or plot the points 0, 1, 0, 2, 0, 3. So if I connect these points, what do we notice? We get exactly y-axis. So x equals 0 means y-axis. And do the same for the line x equals 0. Now let's take a look at slope of a line. So if we take a look at these lines, this line, and then this line, and then this line, we see that each of them, line 1, line 2, line 3, they have different steepness. So this steepness is measured by the slope, and the slope is labeled by m, and it's the rise over run. So basically it's measured by how much it changed in y and how much is changed in x between the 2 points. This would be the rise and this would be the run, which is y2 minus y1 over x2 minus x1, where y2 and y1 and x2, x1 are coordinates of 2 points, right? So point A is of coordinate x sub 1, y sub 1, B is of coordinates x sub 2, y sub 2. So let's find out the slope of a line that is passing through these points. So m equals y2 minus y1 over x2 minus x1. So what I'm going to do, I'm going to write on top of each number x1, y1 and x2, y2. They are always like that. They are not x1 and x2 or x1 and y2. So when we replace, we have -3 minus 2 over 2 minus -4. So when we do the algebra, we get -5 over 2 minus -4, it's 2 plus 4, which is 6. So the slope is -5 over 6. Now let's take a look at equations of lines in slope-intercept form. So in the previous examples, they were in standard form. Now let's take a look at slope-intercept form. The slope-intercept form looks like this. Y equals mx plus b. M is the slope, and b is the y-intercept. So basically, if I have a graph, and this is the line, this would be the y-intercept. So it's of coordinates 0 and some value for y, which we call b. So now let's take a look at the problem that we have here. Example 1. Given 4x plus 7y equals 28, A, write the equation in slope-intercept form. So first, the equation is in standard form. This is standard form. So to write it in intercept form, my goal is to write it y equals mx plus b. That's how we want to write it. So starting from 4x plus 7y equals 28, we want to get y by itself. So first we subtract 4x from both sides. So we get 7y equals -4x plus 28. We write the x term first. We divide by 7 every single number. And we get y equals -4 over 7x plus 4. So now it does look like y equals mx plus b. Then it says determine the slope and intercept. Well, if I compare these two blue equations, we can say m is the number in front of x, so that means the slope is -4 over 7, and b is the constant, which means the y-intercept is 4. This b means y-intercept. And part C, it says graph the line by using the slope and y-intercept. So I want to graph y equals -4 over 7x plus 4. So let's do that. This is the process. I'm going to draw the coordinate plane. And then we start with the y-intercept. So I'm going to go to the y, and I'm going to count 4 units, and I'm going to bubble that. So this is y-intercept. Then we are going to use the slope, which is rise over run, right? So this means go down 4 units. So from this point 4, we go down 4 units. 1, 2, 3, 4. So we end up here. And this 7 says go right 7 units. So then I go 1, 2, 3, 4, 5, 6, 7, and we bubble this. So when we connect these 2 points, we found the equation of the line, and it's passing through this one. The equation of the original line, which was 4x plus 7y equals 28, we made the graph. So keep in mind, when we have m equals a number over another number, right, it can be positive. So if it's the number is positive, we go up from b. If it's negative, we go down from b. If it's positive at the denominator, we go right from where we went before, so where we ended up at the numerator. So when we went down, we got to the origin, and then from there, we went 7 units. And then, so it's not from b, it's from where you are left with the numerator. And then the other option, if it's negative, is go left. And let's talk also about example 2, where it says, write the equation of a line that passes through the point 2, negative 4, and has the slope 3 over 5. So let's say y equals mx plus b. Now the slope, it's 3 over 5. So that means y equals 3 over 5x plus b. This point, so if the line is passing through this point, it means instead of x we can put 2, and instead of y we can put negative 4. So negative 4 equals 3 over 5 times 2 plus b, which means we got an equation from where we can solve for b. So we get negative 4 equals 6 over 5 plus b. We can subtract 6 over 5, so negative 4 minus 6 over 5 equals b. And how do we subtract? Well, we need to multiply this one by 5 over 5. So we get negative 26 over 5 equals b. So in other words, the equation that we were looking for is 3 over 5x minus 26 over 5.